In this video, we will be discussing thermodynamics processes. So we will be discussing how to solve problems with work, with heat, with internal energy, and problems involving isochoric, isobaric, isothermal, and adiabatic process. But for now, we will organize these equations. So first, we have this process, work, W, or our work, Q, and delta U, which represents the internal energy of the system. But first, let us talk about the isochoric process. So in isochoric process, our delta V is equals to 0, or our volume is constant. And since our volume is constant, or our delta V is equals to 0, our work is equals to 0. So remember the equations in the first law of thermodynamics, that delta U is equals to Q minus W. But since W is equals to 0, we have our delta U is equals to Q. Also, we can use this equation for our Q. So, or our heat. So our heat is equals to number of moles and CV, specific heat, in constant volume, delta T, or our change in temperature. So the specific heat in constant volume, so it is the amount of heat required to increase temperature by 1 degree Celsius. So when heat is at the constant volume. And now let's talk about the next process, isobaric isobaric process. So in isobaric process, the pressure is constant, or delta P is equals to 0. So in work, we can use this equation. Work is equals to P delta V, or work is equals to pressure times the change in volume. Also, we can also use this equation. Work is equals to N R delta T. In our Since delta P is equals to 0 and delta U is equals to Q, so we can use this equation. So delta U is equals to N CV delta T. Okay, so delta U is equals to Q. So Q is equals to NCV delta T, which means delta U is equals to NCV delta T. Okay, so Q, since it is constant pressure, instead of using CV, we will be using Q is equals to N, specific heat in constant pressure, delta T. So our next process is the isothermal process. So in isothermal process, the temperature is constant. So which means our delta T, or change in temperature, is equals to 0. Since delta T is equals to 0, so looking back at this equation here, delta T is equals to 0, which means our delta U is equals to 0. And since delta U is equals to 0, so in this equation, delta U equals to 0. So 0 is equals to Q minus W, which means Q is equals to W and W is equals to Q. So to solve for work, we can use this equation. So work is equals to N R T natural logarithm ln times ln Vf, or our final volume, over the initial volume. And to solve for work, we can also use this equation. So QW, so work, or Q is equals to N RT natural logarithm initial pressure over the final pressure. So our next process is the adiabatic process. Adiabatic process. So in adiabatic process, um, Q is equals to C0, because in adiabatic process, it occurs without transferring heat or mass between the systems. So Q is equals to 0 here. So Q is equals to 0, or let us use this here. Q is equals to 0. So since Q is equals to 0, so using this equation, so substitute 0 to Q, we have delta U is equals to negative W. And since delta U is equals to negative W, using this equation here, our W is equals to negative N CV delta T. So what happens what happens to the temperature and pressure if the volume is constant? So if the volume is constant, as our temperature increases, our pressure increases, or we can rewrite this into an equation. So P1 T1 is equals to P2 over T2. How about pressure being constant? What happens to the temperature and volume? So our temperature increases as the volume increases if the pressure is constant. Or making this into an equation, so V1 T1 is equals to V2 over T2. So what happens to our pressure and volume if temperature is constant? We can rewrite that into to this equation. So P1 V1 is equals to P2 V2, or it is when our pressure increases, our volume decreases, or vice versa. Also, we can use other equations, sure, and it is, I think, related to to all of this process. So CV is equals to 3 halves over R, which is, or can be used in this all of these processes.